Alright, we have several derivative rules, but now we're going to talk about the one that brings them all together, and that's called the chain rule. Okay, so what the chain rule does, it allows us to take functions that we already have rules for, which so far are very limited. We have a rule for a power function, we have a rule for log functions, and we have rules for exponential functions. Those are the only specific functions we have. But it allows us to combine those kind of like composite functions, if you're familiar with them. Composite functions where you take one function and plug it into another. In the example of a composite function I have here, f of x equals 4x squared plus 7x minus 4. I'm going to take that function and I'm going to insert g of x into it, and g of x is 3x plus 5. So when I plug g of x in, it goes into every input for f of x. So it makes it a more complicated function, but you can imagine if one of these was a logarithm or an exponential or some other function you haven't seen. So we take the 3x plus 5, we plugged it in everywhere we had x, and it gave us a new function. Okay? But it still breaks down into those two original functions. It's not a product, it's not f times g, so it's not a product rule. It's not a sum difference, it's not f plus g, and it's not a quotient, it's not f divided by g. It is a composite where one function goes into another. So the chain rule definition, I'm going to give you two forms of it. The first one here we have written in the notation that you should be aware of, f of g of x. And we take the derivative of that, it is the derivative of f with g still in it, the original g. And then we're going to tack on the derivative of g at the end. Okay, so that is f prime of g of x times g prime of x. So let's see how that works below. My first example is y equals 7 times the quantity of 3x squared plus 5x minus 4, and all that's cubed. So if I want to make a function decomposition here, usually I'll look for parentheses. Okay, and inside that parentheses I see this 3x squared plus 5x minus 4. So if that was just one variable, like x, we could write it as 7x to the third and we'd feel okay. So let's make that our f. F is going to be 7x cubed. Okay, and what's inside there is the g. The g is x squared plus 5x minus 4. So in that scenario, if I plugged g into the input for f, I would get the original y function back. So let's see, can I find the derivative of each one of these? Well, the derivative of 7x cubed is going to be f prime of 21x squared. G, which is x squared plus 5x minus 4, gives me g prime of 2x plus 5. So I have all the pieces. So let's put this back together as a derivative. It'll be y prime equals f prime. Okay, f prime is 21x squared, but I'm going to leave place here 21 something squared for the g part to go back in. Okay, and remember that g was x squared plus 5x minus 4. And then at the end of this, I'm going to tack on g prime, which was 2x plus 5. Now with that, I can make some cleanup. I can do some distributive property, combine things if I like, but I'm just going to leave it there so that you can see it in its nicest, cleanest form before anything else happens to it. This is the calculus part of it. Anything else we do would be an algebra part. Okay, so let's do another example here. Y equals the natural log of 4x minus 5. So we would not be worried when we look at these parentheses if what was in these parentheses was just x. If that was natural log of x, we'd be fine. So let's break this apart. F can be the natural log of x, and g can be, I don't remember if I wrote beside or under. Let's just erase that. G can be 4x minus 5. So if I plug g into the input x value over here for f, I would get the y function. So f prime derivative of natural log of x is 1 over x. G prime derivative of 4x minus 5 is just 4. So we have f prime, g prime. We have all the parts for the chain rule here. So we need f prime, which is 1 over x in this case, and in that x place I'm going to put g. So that was 4x minus 5. So that is g. And this will be times 4, which is g prime. Now I don't usually clean these up, but it might not be such a bad idea if we did y prime equals 4 over 4x minus 5. And those 4's don't cancel. Okay. So we have g inside of the f prime, and then we have g prime on the outside. The next example, y equals 6 times e raised to the 12x plus 4. So we don't see a parentheses here, but what we think to ourselves is we know the derivative of e to the x is e to the x, but I warned you in the beginning it wasn't always that easy. So we look at this thing, and while there's no parentheses, we can understand that that 12x plus 4 is stuck together. Okay, so there's like a parentheses around it. So if we broke this apart, our f could be 6e to the x. That's messy. Let's clean it up a little bit. 6e to the x. And g will be 12x plus 4. So in that case, f prime will be 6e to the x. And g prime will be 12. So we'll put this back together. Y prime will be f prime, which is 6e to the, and we need a placeholder up here, 4, g, which was 12x plus 4. So it does look a lot like the original, but then it'll be times g prime, which is 12. I don't know why I ended up with green there. But this is the original g, and this is the g prime. So I don't have a lot of room over here, but if I did clean it up, it would look like y prime equals 72 e to the 12x plus 4. All right. Now, the last example, doing it this way, I have y equals 4 times the cube root of 5x to the negative 3 plus 8x. So again, you don't see a parentheses, but a root is telling you that everything under there is stuck together. And if we change that cube root to an exponent, it would look like to the 1/3 with parentheses around it. So that's what we're going to do. We're going to look at this as f being 4x to the 1/3. And we're going to look at it as g being 5x to the negative 3 plus 8x. So derivatives, f prime, derivative of 4x to the 1/3 will be 4/3 x to the negative 2/3. And g prime here, derivative of 5x to the negative 3 will be negative 15x to the negative 4. Derivative of 8x is just 8. So g prime is negative 15x to the negative 4 plus 8. Now y prime here will be f prime, which is 4/3 with a placeholder, which will be the g, to negative 2/3. That's our f prime. So I'm going to stick in g, which we said was 5x to the negative 3 plus 8. And then it'll be times g prime, which will be negative 15x to the negative 4 plus 8. And based off of room, I'm not going to clean that up. Even if you can simplify it, that's fine. I'm just going to leave it alone. So this is one method for doing the chain rule. And what this does with the chain rule is it allows you to approach any function, because you can break it down into two functions you already know. In the next video, I'm going to do the exact same problems, but a little bit differently. All right, thank you.